In lesson 12.2, we're going to look at permutations and combinations. This is a little bit of review. You have talked about these before. First of all, let's define permutation. A permutation is an arrangement of any number of items in a definite order. Order matters. You are arranging or talking about an order of finish, so you're not just selecting a group, and we'll get to what that means with combinations here at the end of the lesson, or the second half of the lesson. So, first of all, 8 people, if you look at this example, enter the best pie contest. They're entering the contest to see who makes the best pie. How many ways can blue, red, and green ribbons be awarded? I'm assuming that blue is first, red is second, and green is third, so you're arranging them in an order. That's what makes this a permutation. Okay? Now, some notation we use with permutations, and then I'll also show you how to calculate this on the calculator. Well, actually, let's look at it with the fundamental counting principle first, and then we'll get into permutations. Okay, counting principle is what we did in 12.1. So if 8 people enter the contest, and you're talking about blue, red, and green, you're arranging an order there. That's what makes it a permutation. We'll get into that here shortly. But if 8 people enter, that means 8 people have a chance to win the blue or first. Once somebody wins the first, they can't finish in the other ones. Okay, that's what makes this a little bit of dependent events. But then you only have 7 people that could finish second, or 7 left that could finish second, and then 6 that could finish third. So if you actually multiplied those together, 8 times 7 times 6, let's go ahead and pull that up. So if we do 8 times 7 times 6 and hit enter, that's 336. So that would equal 336. Possible ways they could be awarded. Now we'll look at permutations here. Permutations, okay? Let's review a little bit with factorial. If you have 4 factorial, here's what that means. 4 times 3 times 2 times 1. If I had 8 factorial, that would mean 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and under your probability mode in your calculator, you probably have a factorial button. And then I'll also get into permutations and combinations that you can do them, whether it's a graphing calculator or scientific calculator. You should have that option for permutations, combinations. This is the notation we use. The P, this capital P right here, stands for permutations. N is the total items possible, so that will always be the biggest number on the left, and then on the right is how many you're going to pick, or how many we are going to arrange, in what order. Okay, this notation, you can either do it with subscripts, number of permutations, N, arrange R, or it almost looks like a coordinate where the total's on the left then, number of permutations, N, arrange R. Now, I'm not going to really show you the longhand way. I might on the first one here, and then I'm going to show you on the calculator. But what we would really have here is, for this example, we're doing the number of permutations, 8 total people in the contest, so it's 8, and we are doing 3 finishes, blue, red, or green, so it would be that. Or, if you do the other notation, it is that way. Now, on the calculator, I am going to show you how to do this. Well, actually, let's do factorial first, and then I'll show you on the calculator. I'll just do this for the first example. So I would do 8 factorial all over N minus R, so I actually subtract these. So if I did 8 minus 3 here, that would be 5 factorial. Now if you think about this, this is 8 times 7 times 6, 5, 4, 3, 2, 1, and this is 5, 4, 3, 2, 1 all multiplied. The 5, 4, 3, 2, 1 cancels, so it's 8 times 7 times 6, which is really what we did here with the fundamental counting principle. But let's show you on your calculator, and I'll show on the graphing calculator, and if you have scientific calculator questions, you're going to have to ask. But what you need to do is, if you look on here, and you go to the math menu, and this is on the 83s or 84, so if you hit the math button, and then you go over here to the probability menu, which means I need to right arrow over to the probability. Notice number 2 there is your permutation button. Now notice there's an N on the left, the P in the middle, and the R on the right. You actually have to enter the N first. So we're going to put in 8, and then I'm going to go to math, over to probability, because we're dealing with probability here. I'm going to arrow down to permutations. I'm going to enter that. This means we put 8 in for N, and then we have to put in a 3 because we're arranging 3. Now that should tell us 336, and it does. So it does that formula for us. So you don't have to write it out the longhand way. You can use your button on the calculator. But notice that does give us, when we do this, 336, which is the same answer I got right there. Permutations. Order does not matter. Permutations with repetition. How many different ways can the letters of the word banana be arranged? Key word right here is arranged. Okay, and you want to think of this. When you have repeated letters, the number of permutations, which P and Q are alike, okay, here's what you need to do. Okay, so we're not going to really use that permutation button necessarily. Notice we have A repeats 3 times, and the letter N repeats 2 times. Okay? If I had a word without any repeats, and I was just arranging all of them, so like let's say for instance I had the word Byron. There's no repeated letters. If I said how many arrangements, and it doesn't say you have to form a word, but how many arrangements of the letters could you have, you really could think of it this way. There's 5 letters, there's no repeats, so it's 5 factorial, or it's 5 times 4 times 3 times 2 times 1. Okay, or it's the number of permutations, 5, arrange all 5. You could do it that way too. You can have those numbers match. Any of those would get you to the correct answer of, I think that would be 120, if there were no repeats. But in this, there are repeats. So what you have to do is, how many total letters are in the word banana? Well, that's 6. So I'm going to do 6 factorial on top, and then on the bottom, I take care of my repeats. In this case, there is 2 of them. A repeats 3 times, so I need to do 3 factorial. N repeats 2 times, so I need to do 2 factorial. Now, you could use the factorial button on your calculator, which will be under that probability menu. I'm going to actually write it out. I'm going to go 6 times 5 times 4 times 3 times 2 times 1. On the bottom, 3 factorial is that, and then it's multiplied by 2 factorial, which is 2 times 1. So here's what we're going to do. We're going to cancel 3 times 2 times 1 with that 3 times 2 times 1. This 2 can cancel with the 4, goes in there twice. So I'm basically left with 6 times 5 times 2, or 30 times 2, which is 60. So there would be 60 arrangements there that we have. And you got to divide by the repeats. How many times they repeated, that factorial. If there's multiple repeats, you'll have multiple factorials on the bottom. Let's go to the next example. And now, actually, the next example, we're going to get into combinations. Combinations is just you're selecting a group. Order does not matter. So if you had the number of combinations and you're dealing with N and R, which basically that's all it is a C instead of a P, The combinations, we're using the same two numbers as a permutation. The combination is always going to be less because there would always be more arrangements, okay, because you're not just selecting a group. And this is the formal definition. I'm not going to get into this, but notice it's n factorial over n minus r. If you took away the r factorial, it would be what a permutation is, but you're dividing by another r factorial. So, and I'll just show you the button on the calculator. I'm not going to have you do it the longhand way, and you'll be able to use your calculators when you're assessed on this stuff. So, 5 cousins at a family reunion decide that 3 of them will go to pick up pizza. How many ways can they choose 3 people to go? What makes this a combination is you're just selecting 3. I'm not saying this person first, this person second, this person third. Then it would be a permutation if you're talking about arranging in an order. You're just selecting a group of 3. So this would be the number of combinations, 5, select or choose 3 to go. Not arranging, so that's what makes it a combination. Or the other notation, you're doing that. And then let's just use our calculator. So let's go down here and let's grab our calculator. So let's put the 5 in, and it's the same as before. We're going to go to math. We're going to go arrow over to probability menu, and we're going to go down to combinations, which is the one below permutations, because we're doing a combination on this. And then we're going to put in 3, and the answer would be 10. So there's 10 possible ways. And if you did it the longhand way, you would have 5 factorial all over 5 minus 3 factorial, which would be 2 factorial, and then r factorial. This would be r, and this is n, so 3 factorial. So just showing you that the longhand way works. 5, 4, 3, 2, 1. 2 times 1. 3 times 2 times 1. They cancel. 2 goes into 4 twice. Notice I'm left with 5 times 2, or 10. So if you didn't have a calculator, you could do it the longhand way using the formula. Last thing we're going to look at here. Just talk a little bit about Pascal's Triangle. Another way to find the combinations is by using Pascal's Triangle, and this isn't really in your notes, and this deals with combinations. Pascal's Triangle, and we'll deal more with this later, but Pascal's Triangle is basically a triangle of numbers. You got a 1 at the top. We actually call this row 0. This is row 1. Okay, the 1 and the 1, and then it's 1, 2, and 1. This number comes from adding the 2 directly above it. So for instance, this 28 right here down in this row would come from adding 21 and 7. Okay, so you could make that triangle. I don't know what row we're down to here, but this means the row n. So if I had 5 and then 3, I'm going to go to row 5, diagonal 3. This would be diagonal 1, diagonal 0. Then diagonal 1 is this one right here, diagonal 2, and so on. So this right here is diagonal 3, and row 3, notice that's a 10 there. So Pascal's Triangle is just a little pattern triangle that you can deal with in combinations. Now you're going to use the calculator, but that's just a little side note there. Multiple events. 6 cards are drawn from a standard deck of cards. How many hands consist of 2 hearts and 4 spades? What we're going to do is we're going to multiply the number of ways of selecting 2 hearts and 4 spades. And this deals with combinations, because we're just selecting 2 hearts and 4 spades. So combinations there. That's what we're dealing with. So we're going to do 2 hearts. So I'll do hearts. Number of combinations of selecting 2 hearts. So I have to do the total number of hearts that I have in a deck. There's 4 suits, 52 total cards, 13 of each suit, so there's 13 total hearts, and I'm selecting 2. So that would be the ways of selecting 2 hearts. And then I go to spades, and there are also 13 spades, and I'm going to select 4 of them. And I multiply these 2 together. So the number of combinations, 13, select 2 hearts, times the number of combinations, 13 spades, select 4. And if you actually calculate that out, do it on your calculator. I'm not going to show the calculator here, but if you did the number of combinations, 13, select 2, you'd get 78. If you do this one, it's 715. You multiply them together, so it's 55,770. And you can check that on your calculator using your combination mode.